Hi girls, this video is in Unit 4, Lesson 4.1.2, Comparing Data Sets. So the first thing we're going to talk about is measures of center. Let's talk about a few key concepts that we need to look at. Measures of center such as the mean and the median, we've talked about these, describe the expected value. And we said that we would look for that word expected value when we were determining which type of graph to graph. And when we saw expected value, we said we should think box plot because we have a median in a box plot. The median, the mean, or the average is influenced by very small or large data values, whereas the median is not. We've also talked about the measure of spread, and that describes the range of the data. How spread out is the data? The interquartile range, something we haven't discussed yet, is a measure of spread, and the mean absolute deviation is a measure of spread, and we'll learn how to do those a little bit later in this video. So the interquartile range shows the range of the middle 50% of the data set. We talked about that today when we looked at that rectangle. It's the difference between the first and the third quartile. So you just take the third quartile and subtract the first quartile from it. The mean absolute deviation compares data values to the mean or the average of a data set. If the mean absolute deviation is large, this is a sign that the data points are distributed farther from the mean. So two or more data sets can be compared. We can use measures of center and spread. So when choosing a measure of center or spread, we have to identify if there are very large or very small data values that may influence the mean. And as we've seen, data can be compared graphically. The shape of a data set can be seen in a frequency plot, such as a dot plot or a histogram. So let's look at this dot plot. The data in this dot plot is symmetric because it is concentrated around the middle of the data set. And you'll notice that it looks very similar on both sides. And as we know, when something is symmetric, there is a center or a fold line. If I was to fold this dot plot onto itself, the dots would line up one on top of the other. So symmetric means that the data is concentrated towards the middle of the range. We can also have data that we call skewed to the right. Try and get it a little bit closer here. There we go. Skewed to the right data is concentrated towards the lower range of the data. It has a tail to the right. Okay? So most of my data is over here on the lower end of my scale, and the tail, it trails off. The tail is to the right, so it's considered skewed to the right. In this data, most of the data is concentrated on the higher numbers, the upper range of the data, and it has a tail to the left. So we look at the tail to tell us how the data is skewed. Tail to the right, skewed to the right. Tail to the left, skewed to the left. So data that is widely or evenly distributed has a greater variation. Okay? So the more evenly it's distributed, the greater the variation. If data clusters around a certain value, then it has less variation. And we can also compare data using a box plot. The width of the box displays the range of the middle 50%. Remember, I said that today. 50%. The width increases as the variation increases. So let's look at our first example. This is on page, we're going to need pages 21 through 24 of your workbook. So go and get those. All right, so let's try and see this whole page. So our practice problem says, two hockey teams recorded the number of goals scored each game in the tables below. Use the tables to compare the expected number of goals scored per game for the two teams using both measures of center and spread. Okay, measures of center and measures of spread. So we've got the Ice Kings and the Gliders. So the first thing we need to do, if we look at page 22, is determine, it says determine which measure of center to use. Order the goals scored for each team from least to greatest. So I'm going to work first with the Ice Kings. And the data for the Ice Kings looks like this. So, got 0, 0, 0, and that's it for my zeros. 1, 1, that's it for my ones. 2, 2, 2, 2, 2, 2. No 3s, no 4s. 5, 5, and 6. So this is the Ice Kings. Next, we're going to look at the gliders. So the gliders, 0, 0, 0, 1, 1, 2, 2, 2, 3, 3, 3, 4, no 5s, 6 and 6, 6 and 6. All right, and this is for the gliders. So we're going to look at the range of the data is the next thing that it says to do. And so we're going to determine if there are any data values in either table that are much larger or much smaller than the rest of the data set. If there are, use the median. If not, we could use the mean or the median. So most of the numbers fall between 0 and 6 here, and most of the numbers fall between 0 and 6 here. Okay? So there's really not that big of a difference. So we could use either the median or the mean. So let's find, let's pick the mean for this, which means I have to add all of these up, 0 plus 0 plus 0, add all of these up and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm going to add all of these numbers up in my calculator and divide by 14, and I'm going to, I use the mean here. So for team number 1, the Ice Kings, when I find the mean, it's about 2.14. Oops, can't see that. I'm going to do the same thing with team 2, the gliders. I'm going to add all of these numbers together. I'm going to divide them by 14. And for team 2, I get 2.36. So again, those numbers are fairly close. So it says that in any given game, you could expect that either team is going to score at least 2 goals. That's how we would compare this measure of center between the two teams. Team 1 is expected to score a little bit more than 2 goals, and team 2 is a little bit more than 2 goals also. Now there's one more thing that we can do to look at this data, and it's called the mean, the sum of the absolute differences. Okay, so we're going to look at the absolute mean difference. And what that means, absolute value, remember, we use absolute value bars. So if I had the absolute value of -5, it would be its distance from 0. So 5 is 5 places away from 0. So we need to use our absolute value bars. And in this case, what we're doing is we're taking our data point and we're subtracting what we found the mean to be. So for this team, we found it to be 2.14, 2.36. So the first one for the Ice Kings, we find the absolute value of 0 minus 2.14, the absolute value. And that is 2.14. Same thing for this, 0 minus 2.14, 2.14, 2.14. For 1, we would take the absolute value of 1 minus 2.14, and that's going to give us 1.14. And we have another one, so that's 1.14. Here we're going to take 2 minus 2.14. The absolute value is going to give us 0.14. So 0.14, 0.14, 0.14, 0.14, 0.14. Here, the absolute value of 5 minus 2.14, and that's going to give us 2.86, 2.86. And then 6, the absolute value of 6 minus 2.14 is going to give us 3.86. So again, we are finding the mean absolute deviation, which means absolute value of the data point minus the mean that we have already found. Now, we can sum all of these and find the mean absolute deviation. So basically we're taking the average now, we're finding the mean of all of these absolute deviations. So I'm going to add 2.14, 2.14, 1.14, 1.14. I'm going to add all of these together, and then I'm going to divide by 14. So when I add all of these together, my total down here is 19.12, and then I'm going to divide that by 14. So my mean absolute deviation for team 1 is going to be 1.37. So now I'm going to do the exact same thing for team 2. Again, I start with 0, but this time the mean is 2.36 minus 2.36, and that gives me 2.36. So 2.36, 2.36. In this case, it's 1 minus 2.36, the absolute value. That's going to give me 1.36, 1.36. Now my data points are 2. 2 minus 2.36, the absolute value, 0.36, 0.36, 0.36. 3 minus 2.36, that's going to give me 0.64, 0.64, 0.64. Absolute value of 4 minus 2.36, that's going to be 1.64. And then 6 minus 2.36 is going to be 3.64, and another 3.64. So once again, I'm going to total all of these, and for the total, I'm going to get 21.72. I'm going to divide that by 14. So for team 2, my mean absolute deviation is going to be 1.55. So what does this tell us about our data? It says that team 1 has a slightly lower mean, but the number of goals scored per game also varies less than team 2, the Gliders. The Gliders has a higher mean, but it also has a higher variation. All right, so let's look at some data in a different format. Let's compare two dot plots. So it says each girl in Mr. Sanson's class and in Mrs. Kwai's class measured her own height. The heights were plotted on the dot plots below. Use the dot plots to compare the heights of the girls in the two classes. So first let's look at the ranges. So in Mr. Sanson's class, the range is from 59 to 72 inches. In Mrs. Kwai's class, her range is from 60 inches to 72. So they have very similar ranges. Now let's compare the middle values of the data set. So if we look kind of where the middle falls for Mr. Sanson, we see that the most girls appear to be 67 inches. So let's get a different color here. So if we look at the middle values, where are the data points clustered? So in Mr. Sanson's class, they seem to be clustered around 67. And in Mrs. Kwai's class, they seem to be clustered around 65. So their middles are a little bit different. So now when we look at comparing the two data sets, we'll notice that the variation in the two sets appears to be similar. They have similar ranges. But if we look at Mr. Sanson's data, he seems to have a tail headed off this way. So we would say that his data is skewed to the left. And Mrs. Kwai's has a tail headed this way at the upper part of the data. So we would say that she is skewed to the right. So we would say this is skewed to the right. And Mr. Sanson's data was skewed left. The majority of the girls are within 6 inches, or approximately within 6 inches. The majority of the girls in Mr. Kwai's class seem to fall between about 64 and 70. Mr. Sanson's class, and in Mrs. Kwai's class, they seem to fall mostly between about 61 and 67 inches. All right, let's look at our last example of a box plot. So example 3 says, Sam wants to buy a lottery ticket. There are 2 different tickets that he can buy, and each costs $10. He found a website with information about how much money others have won with their lottery tickets. The information is presented in 2 box plots shown here. Use the 2 box plots to compare the amounts others have won with ticket 1 and ticket 2. So let's compare the range of the data. So the ranges seem to be similar. So in this case, our data points range from 0 to 25. $0 to $25, and the range in ticket 2 seems to go from 0 to about halfway between 20 and 25, so that's about $22.50. So they have very similar ranges. So let's look at the center of the data sets. Well, we know the median here because our middle line here tells us our median. So in this case, our median is 6. And in this case, our median is 5. And remember, the median splits the data in half. So for ticket 1, half the data is below 6 and half the data is above 6. For ticket 2, half the data is below 5 and half the data is above 5. Now, something we haven't spoken about yet is something called the interquartile range. Let's write that. The interquartile range. And we abbreviate that as IQR. So to find the IQR, we take the third quartile. We take the third quartile, and we're going to represent that by Q sub 3, which in this case is a line at about halfway between 10 and 15. So that looks like it is 12.5. And our first quartile, Q sub 1, seems to be at 5. So to find our interquartile range, we take Q sub 3 minus Q sub 1. So Q sub 3 is 12.5 minus 5, which is going to give us 7.5 for our IQR. Over for ticket 2, The third quartile is about halfway between 15 and 20, so that's about 1750. And the first quartile is at 4. So our IQR would be third quartile minus first quartile, so 17.5 minus 4, so about 13.5. So when we look at that, we realize that ticket 2 has a much larger interquartile range. So because there is a larger interquartile range for ticket number 2, but it also has a lower median, it's more likely that Sam would win more would be more likely to win more money with ticket number 1. All right, that's it for this video. I thought originally I'd do a second section, but I think this will be enough for tonight, and we'll do some practice problems tomorrow in class, and then maybe if we get a chance to, we can move on to 4.1.3. See you tomorrow.